Hi all, welcome back to my channel. Today we're going to be looking at simultaneous equations. So this is at Year 10 mathematics level in the Victorian curriculum. Let's get into it. So our learning intentions for today are to understand that a single linear equation in two variables has an infinite number of solutions, to know that two simultaneous linear equations or straight lines can have none or one solution, which is what we call points of intersection, to understand that the solution of two simultaneous equations satisfies both equations and lies on both straight lines, to know how to substitute one algebraic expression for another to obtain an equation in one unknown, to be able to solve simultaneous equations using the substitution method, to understand that multiplying both sides of an equation by a constant produces an equivalent expression or equation, to know how to use the lowest common multiple to obtain a matching pair of terms in two equations, and to be able to eliminate a polynomial by adding or subtracting two equations with a matching pair. This sounds like a lot of stuff, but we can condense it into some very simple ideas. So let's get into it. So what are simultaneous equations? Well, simultaneous equations are two or more graphs that are occurring at the same time, or equations that occur at the same time. In Year 10 we look at two equations or rules, which obviously we look at as linear graphs. If you go into VC, you're looking at non-linear graphs with simultaneous equations. With two equations we can only have one or no solutions. This is because it is representative of the amount of intersection points of a linear graph. So if I have two lines that are straight, there's only one point where they can cross, which is here. This is our solution. So what this also means is that our solution will have an x and a y value because it's on a Cartesian plane. When there's no solutions, we're working with parallel lines. The only time two straight lines don't intersect is when we have two parallel lines. So what I should be looking for in terms of this is the same gradient. So how many solutions with one equation on a graph? So if we look at the rule x plus 5, what solutions can we have for this equation? I want you to write down a few solutions that we could potentially have for this one particular equation. Had some time? Good. So I'm going to write some down. I can write 1 plus 4 equals 5. So I could have x equals 1 and y equals 4. I can have 2 plus 3 equals 5. So x would be 2 and y would be 3. I could have 0 plus 5 equals 5. So x could be 0 and y could be 5. We can see there's if we keep going, we can do this forever. We can start working with decimals. We can see that we can't find a definitive value for x and we can't find a definitive value for y because any combination of two numbers could add to equal 5. This is why we have two equations. So what methods of solving simultaneous equations we have? Well, there are three ways. First way is the substitution method, which is where we substitute an equation into another equation. We have the elimination method where we subtract or add the equations together to remove one of the variables. And we have the graphical method where we sketch the graphs and we find the intersection point. For the sake of this, we tend not to look at graphical at this level. We're really focusing on substitution and elimination method. You are more than welcome to check by sketching the lines, but it's not necessary. All methods, all three, are looking for a point that each equation has in common on the graph, which we call the intersection point. So keep that in mind when you are working through this. The substitution method requires you to substitute one equation into another. It is implied that equations have to be equal to each other in order to find a point in common. The steps we take are: make one equation with x or y the subject. So what we should be looking for is something that looks like this. or whatever letter. We could go plus 3, or we could have v equals s plus 2. Doesn't matter what it is, as long as it's a letter equals something else. So having a letter, the subject. Normally we work with x and y, but if we have application problems, we can of course have different letters. We substitute that equation into the other equation in the x or y value, depending on whether you made this equation x equals or y equals. So if I have x plus y equals 5, and we have this, just say we have this, what we could do is we could substitute this where y is, and we could have x plus 4. So we're replacing the y with an x. The point of this obviously is to solve for the unknown. As we mentioned earlier, we can have multiple values or multiple solutions from two variables with one equation. When we substitute, we create a situation where we've only got one variable in one equation, which means we can actually solve it. Once we've solved for that unknown, we use the other value to find the other one. So if I was to do this one, I'd have 2x plus 4 equals 5, and then I'd subtract 4. So this is my solving part. 2x equals 1, so x must be equal to a half. If I was to work back and I was to substitute that back into here, I'd go a half plus y equals 5. So therefore we know y is equal to 4.5 or 4.5. So that's the general gist of how we do substitution. So let's have a look at some examples here. When we get to it. So we have 2x plus y equals negative 7, and we have y equals x plus 2. So our first thing is to determine that we have an equation that has y or x or any letter as the subject. What that actually means is that one side only has one letter. So in this case, we have y equals, so y is the subject of this equation. So we're going to substitute this. Now I'm going to label this as equation 1. I'm going to label this as equation 2. So what I'm doing here is I'm subbing equation 2 into equation 1. So what we've got going here is that is going to go where that y is. So I'm replacing the y with x plus 2. The reason why I do that is because I want only one variable with my new equation after it's been substituted. Here we can see they're all in, there's only one variable now instead of 2 in equation 1, and that means we can solve it. So 2x plus x gives me 3x plus 2 equals negative 7. We subtract 2 to both sides. So we have 3x equals negative 9. So x must be equal to negative 3. So we've got our x coordinate of our intersection point. We now need to find our y coordinate. The cool thing about this is I tend to we tend to have an equation as the subject, and putting it into that one makes it very easy to calculate. So I'm going to substitute x equals 3 into equation 2. So it's going to be y equals negative 3 plus 2. And we've got y equals negative 1. So the intersection point of these two equations is negative 3, negative 1. So if I was to draw this on my CAS calculator, or if I was to sketch it by hand, I would see the point that they cross over at is negative 3, negative 1. For the second question, it's much the same, except something I need to be aware of here is that we have negative 3y this time instead of a positive y. Why this is important is because a lot of these people come undone with these types of problems, not because they don't understand how to actually use the substitution method, but actually how to evaluate negative numbers. So in this case, I'm going to substitute x plus 3 where that y is. So I'm going to rewrite equation 1 with the y replaced with x plus 3. I make sure I put brackets around what I substitute because that negative 3 affects the x and the 3 when we expand it. So I'm going to expand it here. So minus 3x minus 9 equals negative 8. We've now got minus x minus 9 equals negative 8 plus 9 plus 9. Negative x equals 1, so x must equal negative 1. My last step is to substitute it into my second equation, which gives me 2. So y is equal to 2 and x is equal to negative 1. So our intersection point in this case would be x, well, negative 1, comma 2. So here's one for you to try yourself. This one's a bit tricky because we have both of them as y the subject. I'm going to pause now. I would pause the video now and have a go with it yourself. Okay, let's go through the solution. We have y equals negative 3x plus 2 and y equals 7x minus 8. If they're both equal to y, one way we can look at it is if that's y equals, it means I can substitute this into this. So I can replace that y with negative 3x minus 2. So I can write that as negative 3x plus 2 equals 7x minus 8. So I've substituted equation 1 into equation 2 in this case. So there's equation 1 and there's equation 2. Now we would solve it. So we're going to add 3x to both sides because I like to work with positive numbers. You can minus 7x, that's perfectly fine as well. We have 10x minus 8. So I'm going to add 8 to both sides. And then we've got 10 equals 10x, so therefore x must equal positive 1. Now I need to substitute this in. I'm going to substitute it into equation 2 just because I can, doesn't really matter. And we should end up with negative 1. So our point will be 1, negative 1. So hopefully you got that. If you don't, make sure you look over your steps and see sort of where your errors were. So the elimination method requires you to eliminate a variable adding or subtracting one equation from another. This can only happen if the coefficients are the same magnitude. Now that says they, it's actually meant to be the. Let's cross that out. So magnitude is size. So negative 3 and 3 have the same magnitude because they have the same number, but obviously they're different values. Okay. Let's add some equations together just to see how we go about it. So if we look at this, the way I like to write this is actually to write them underneath each other. So I'm going to add these two together. If I add them together, I'm going to add this equation to this equation. I've got 2x plus x gives me 3x. 3y plus 4y gives me 7y. 6 plus 8 equals 14. So in this case, if we add the equations together, we don't eliminate a variable. So remember, the ultimate goal for adding and subtracting equations is to eliminate a variable. I'm going to do the same thing with the second lot of equations here. So we've got 2x plus 2y equals 9. I'm going to add them together. Negative 2x plus 2x is 0. 3y plus 2y is 5y. And then 6 plus 9 gives me 15. So in this second two equations, what we've got is a scenario where the x's have been eliminated. And what I should also see is that negative 2x and 2x are opposites of each other, or inverses. So negative 2x and 2x, when added, gave me 0. So what we should notice is that when we add opposites, they eliminate each other. And we need the same magnitude, so they have to both be 2's. In the first one, they had different magnitudes, so we weren't able to do it in either way. Now, how would they? I want you to have a think about, before we move into the strategies, how this would look if we subtracted the equations from each other. The strategy for the elimination method goes as follows. 1. Make one of the variables in each of the equations the same magnitude. So we could make it as negative 2x or 2x, or we make them as 2x and 2x. So either opposites or the same. Add the equations if they are opposite operations, and subtract if they are the same operations. So if they look like this, we are going to add them. If they look like this, we're going to subtract them. Solve for the one unknown left over. So we noticed in the previous section, we found that when we added the opposites, we were just left with a y variable and a number. So in that case, we were able to solve quite easily. And then the last step, which is to use your solution to find the other value, which we did with the substitution method. So that step does not change regardless of which method you use. Remember, there should always be an x and a y solution, or two solutions with simultaneous equations. So let's do some solving equations with using the elimination method. So what you might notice is I like to put these on top of each other. So we've got x plus y equals 6. 3x minus y equals 10. Now, in any situation, we can eliminate x or we can eliminate y. Now, I'm going to call this equation 1 and this equation 2. What I'm looking for first is something that has the same magnitude, either x's or y's. What I notice here is with the y's, here, we have, they both have 1 in front of them. So one's positive 1y and one's negative 1y. So I know they have the same magnitude. So I'm going to work with those two. If I wanted to remove the x's, I need to make the equation 1 3 times bigger to make it 3x as well. So I'm going to avoid doing that. If the second part is that because I'm focusing on that, I have to determine whether I'm going to add the equations together or subtract. Remember, as we said in the previous section, that if we want to eliminate opposites, we have to add them together. So I'm going to add the two equations and then work down the page. So I'm going to go x plus 3x gives me 4x. Y plus negative y gives me 0. And then 6 plus 10 gives me 16. So what I'm left with is 4x equals 16. So therefore x equals 4. The cool thing about the elimination method is that when we do eliminate it, we end up with usually a rather simple solving equation in order to get our first variable. From here, we have to substitute. I'm going to sub x equals 4 into equation 1. Just because it's going to be easier. So I'm going to have 4 plus y equals 6. So all I've done is I've grabbed this and put that into here. So subtract 4 to both sides. So y must be 2. So my solution for this must be 4, 2. So this intersection point of these two graphs will be 4, 2, if we were to look at it graphically. We have two more examples that we're going to go through here. first one, we have y minus 3x equals 1, 2y plus 5x equals 13. What we notice here is if we look at the y's, we have y and 2y. They don't have the same magnitude. 1 is 1y, 1 is 2y. And if we look at x's, they also don't have the same magnitude. One has a 3 in front of it and one has a 5 in front of it. So what that means is I have to change the equation so that one of them has the same magnitude as the other. Now I could do x's, but in order to get that, I'd have to find the lowest common multiple of 3 and 5, which would be 15. So that means I have to times the top one by 5 to get it to 15x, and I'd have to times the bottom by 3 to get it to 15x as well. However, if I look at the y's, if the lowest common multiple of 1 and 2 is actually 2, so I only need to double the first equation to be able to make them the same magnitude. So if we have equation 1 here and we have equation 2 here, what I'm going to do is times equation 1 by 2 so that I can get everything multiplied by 2. So what we have here is, here's our equation. I'm going to times the whole thing by 2. So what we should end up with is 2 times y is 2y, 2 times negative 3x is negative 6x, and then 2 times 1 gives me 2. Now what we've got, if we look at our two equations, we'll call this equation 3 just so that we don't get confused. We should see that both of them have a 2y in it, so we can actually work with them. So I'm going to do 2 take away 3. I'm going to take away because they are the same term. They're both positive 2y's. And the reason why I'm doing 2 take away 3 is because, well, I feel like it. It doesn't really matter. We can do 3 take away 2. We just end up getting negatives and positives in different spots. This is where a lot of people will come unstuck because this is where we start working with positive and negative numbers. We have 2y take away 2y, which gives me 0. 5x take away negative 6x. So that's 5x take away negative 6x, which is actually 5x plus 6x, which is 11x. So if you need to do a little calculation over the side because you find that kind of stuff difficult, then do it. 13 take away 2 gives me 11. So we've got a nice easy calculation here. X equals 1. We're now going to put that back in. I might chuck it into equation 1. So we're going to have y minus 3 bracket 1 equals 1. Y minus 3 equals 1 plus 3 to both sides. So y must be 4. And my solution is 1, 4, or my intersection point. Hopefully you've liked today's lesson on simultaneous equations. If you liked it, give it a thumbs up. If you don't, let me know what I can do to improve it. And thanks for watching.